Hello everyone, hope all is well. My name is Muhammad Farahat. I am a geologist. As usual, safety first. Before we start our quick journey today, a safety moment. Just a gentle reminder, please keep up the social distance the right way. Avoid the corona by follow health instructions and apply all of the protection rules as much as you can, if you please. I wish you all a happy times. Geoscience Tricks of Field Development Plan. This is the title of today. Actually, this is a second session regarding the FDPs. Last session was dedicated to science, reservoir engineers, and so this one too. Now, I talk from geoscience tricks point of view. So I call it tricks because it's appearing during constructing the 3D model due to revise the input data again or while determining the uncertainties. What is the agenda of today? The key uncertainties challenges of FDPs, applied science tricks, the main focus, way forward. Keys. The main keys required for the FDP's execution are mainly all of the geoscience and engineering disciplines. If we start with seismic interpretation, there are different methodologies for every individual activities, standalone or integrated with the others. I'm going to focus a bit today on some aspects of these keys related to the petrophysics. Also, maybe some lights on uncertainties, challenges, and strength values of the petrophysical model for the FDP's success. Now, uncertainties. The expected uncertainties of field development plans, studies, or projects. Petrophysical modeling related are: number one, geological setting, reservoir characteristics, production performance. Geological settings means, is it clastics or carbonate or both? Is it combination reservoirs? Is it shallow or deep target? Reservoir characteristics estimate and calculate the permeability, the saturation, effective porosity, total porosity curves. However, production performance, in order to set up the workover plans and optimization predictions. Challenges. Mainly, we got to expected petrophysical challenges for FDP's projects. Geological zonation, which determined by the area geologist. The previous slide mentioned the reservoirs base lithologies as one of the petrophysical uncertainties through the geological setting concerns. Effective or total porosity of the saturation. Anyway, the petrophysical curves matters. The total estimation curve or effective. Based on enough experience of the petrophysicist, I mean the legends or the principles of the of the petrophysicist, they are giving a great hand in determining and creating the geological zonation, particularly for those fields of multi-reservoirs, maybe different lithologies of carbonate and clastics as well. Very much help to the fields with highly heterogeneous sediments. So now we understand that petrophysicist has a very strong strength. So what is the strength? To continue that challenge, highlighting the strength of the petrophysicist. The other major challenge of FDP's project or studies for the petrophysical disciplines is reservoir properties. Indeed, it's one of the petrophysicist's strengths for optimizing production and for sure workover plans. For sure, massive operation items on Gantt chart of the FDP's projects. Applied science and tricks. So I have mentioned during the introduction about that word I used, tricks. So what's the tricks here? It seems now the mission accomplished. Petrophysical task done already, okay? Since the petrophysicist has provided and helped other disciplines, reservoir petroleum production, drilling engineers, inputting and setting up and design the workover plans and provided the best candidates intervals for the well testing and so on. All of the other good deeds, everything perfect. So عفاري يا شباب. But things, issues happen, emerged unexpectedly. So that must require revising. Maybe so tricks appears. Now we can see the tricks highlighted with these circles. So what is the main focus? Currently, or just let me please explain some things first to know how it goes nowadays with the geomodelers. They are making copies of the petrophysical raw logs or raw curves to be used for the 3D static modeling. These copies allows manual editing for intervals, some intervals of the reservoir sections, not the base, either with -999, which is undefined, or maybe the minimum to be edited these intervals with the minimum, for example, effective porosity percentage. So in case we are in that carbonate reservoir, so maybe the minimum effective porosity to produce oil maybe 6 or maybe 5 or 6 percentage of the effective porosity. So they put it instead. That in order to eliminate any distribution exaggeration. So the main focus is data analysis and the eye dissections creation. Let's start with the data analysis. Actually, the field trip is the start, the good start, the perfect start for the data analysis from petrophysical point of view, to understand, to realize the heterogeneous reservoirs, I would say. That was field trip in Ashford and different features, and there was an environment as well. So regarding the island sections, now it's quite obvious that the petrophysicist is the best candidate for the 3D modeling construction. I mean, the mission itself goes to the petrophysicist as a best candidate. Why? It provides required and correct curves effectively for population in 3D. This is the cross section. To differentiate between the effective and the total. For example, the effective porosity. And this is how it looks like in the last shape, without any crossover values, or that values with 0, 0, 0 for effective porosity, which is wrong. But the way forward, I got just only a very quite interesting case study for well, number 1 has been drilled with a sharp contact of oil-water contact, and second well on the right hand side has been drilled, and the difference between those two wells just only 800 meters. However, we got two different sharp oil-water contacts from seismic and the geological works or results or estimations, and the formation stops and the markers. All of these has determined at every well that there is no barriers or minors or major faults noticed between wells, even from the production itself. Has been confirmed. There is the production engineer did not feel any sort of faults or barriers. You have drilled the third deviated well, and he confirmed the sharp contact, the higher one, sharp contact. So the petrophysicist integrated with the geologist in order to provide the solution here. So you can see there's two different sides of that 3D conceptual model might provide the solutions. Thank you, and I wish you all the best. Bye bye.